This is the fourth practice problem from FRQ practice packet. Probably the most difficult of the four. So we're going to start by looking at part A, which has two parts to it. Notice that when we solve, if we do find solutions that do need to occur from 0 to 2 pi, we can include 0 and include 2 pi. Let me flip this over and let's get started. Oh, I got the wrong one. Here we go. All right, so we're told that we're going to set g of x equal to -4, and we're told that g of x equals 2 secant of x minus pi divided by 3. So I'm going to start by dividing both sides by 2, and then on the left-hand side I'll simplify that to equal -2, which is the same as -2/1. Now, I know that the relationship between secant and cosine is that they are reciprocals. So I can change this into a cosine and take the reciprocal of the left-hand side. And I've done that right here. Then I'm going to ask myself, okay, if I let x minus pi over 3 equal u, this would look like -1/2 equals the cosine of u. Where can I find values on the unit circle between 0 to 2 pi that have a cosine value of -1/2? And we can find those at 2 pi over 3 and at 4 pi over 3. How did I come up with that? I quickly do the 1, 2, 3, 1, 2, 3, recognizing that the 2's and the 3's get a square root in the numerator and everything has a 2 in the bottom. Well, that looks very messy. But we can see right here that our first value is our cosine and we have a 1/2, but I want a -1/2. So the reference angle is the 60 degrees or pi over 3. When I look at my other options here, the only two that have a negative cosine would be at 2 pi over 3 and 4 pi over 3. So now I'm going to change it and I'm going to write it as, and you can see my work for both parts here. I'm going to take 2 pi over 3 and I'm going to set it equal to this quantity right here. So the cosine of -1/2 is 2 pi over 3 and 4 pi over 3. And then I'm going to set it equal to this u quantity. And if that's making it a little confusing, think of this. The cosine of 2 pi over 3 is -1/2. The cosine of 4 pi over 3 is -1/2. That's how I'm now going to set it equal to this u quantity. So I'm going to add pi over 3. You can see we have a common denominator of 3, and 2 pi plus 1 pi is 3 pi. It simplifies down. I'm going to add pi over 3 to the other side. Again, we have a common denominator, and 4 pi over 3 plus pi over 3 is 5 pi over 3. Let's go on to the second question. Now, in the second question, I provided that h, and let me move this up even further so you guys can see as I go through this with limited space. We're told that h of x equals -4, and then we're told that h of x equals log base 3 of the quantity x plus 2, subtract log base 3 of x plus 1. As a quick reminder, the values you have inside here is the base and the value behind always have to be greater than 0. So I'm going to take and condense this. On the right-hand side, I know that when we condense it, subtraction turns to division. And then I'm going to rewrite it in exponential form. So the base remains the base. So 3 remains the base. I'm going to go across the equal sign and raise it up to this value. Now this means that this 3, this is exponential form, but this means that this 3 isn't happy being on top. We're going to rewrite it on the bottom. And now I'm going to do cross multiplying. 1 times x plus 1, 1 times x plus 1. I know 3 to the 4th. Well, 3 squared is 9, and 9 times 9 is 81. So 81 times quantity x plus 2. And then I distribute the 1 and distribute the 81 and do this simple algebra. I'm going to choose to move the x's to the right-hand side, and we're going to take the values that have no x's and move them to the left-hand side. And so this is what I come up with. Now, is that the answer? If we look back to the question, let me flip it over here. It says within the domain of h. So they're really testing you. Do you understand what you're allowed to plug in for the input values? That's our domain. Remember, as I stated up here, that this value and this value have to be greater than 0. So when I look here, I know that if I double 80, I end up with 160, but this is slightly more than 160. That means this value is going to be, if I'm going to guess, it's going to be -2 and it's going to have some value. Maybe it's like 0 something, but it's on a number line. here is negative 2, and it's going to be slightly to the left of negative 2. So if you think of this 2 point something, I don't know if it's 2.1, but I'm going to guess it's like negative 2.0, 1 or something. But we don't have to take time to divide that out by hand. What I know is this: if I come back to this original problem, and I know that these two values have to be greater than 0. If I take a value that's negative 2 something, and I add 1, I still am left with a negative value. What does that make this? I'm going to cross this right and write extraneous solution. And what does that mean? It means that this particular value, although all the math works out, when I check it with the original problem, it's going to break a math rule. So we can't consider it as an actual solution. Let's move on to B. At B, we're provided with a J and K, and then it says specifically for J, we're going to rewrite this as the product of secant and cosecant. So we're going to rewrite it in equivalent form, having only secant and cosecant as the trig functions. And then for part 2 of B, we're going to condense this as a single natural log with no negative exponents. Let's get started. Okay, so I'm provided with the tangent. J of x equals the tangent of x plus the cotangent. Well, we can rewrite tangent is sine over cosine, and cotangent is cosine over sine. And then I'm going to do the butterfly method. So I'm going to multiply down here. Sine times sine is sine squared. I bring down the symbol, and then I do the next diagonal. Cosine times cosine is cosine squared. Now don't forget, in the denominator, we're going to multiply the two denominators from up above. Now, the most famous or well-known Pythagorean identity in trig is that sine squared plus cosine squared equals 1. And now I can separate this as 1 over the cosine times 1 over the sine. And I am aware that 1 over cosine is the same as secant, and 1 over sine is the same as cosecant. Let's go on to the second part. In the second part, we're provided with this long, expanded natural log function, and I want to rewrite it as a single natural log. So if we had any values up front, they're going to turn into exponents as we condense this. Subtraction turns into division, and addition turns into multiplying. So my first step is I have the ln of x to the third divided by x plus 4 raised to the 1/2 power. And I'm going to multiply that by x, 2x minus 1 on top. And now when I push these together, you can see this is what it looks like. I multiply straight across. And as a reminder, we do want to note that we can never have a denominator. We can never have that denominator equal to 0. In fact, even more than that, remember that we're looking at real solutions here, and we can't take the square root of a negative. So x plus 4 must be greater than 0. Let's move on now to part C. I really enjoyed doing this problem because it made me think. I was stumped here for a minute too, thinking like, what can I use? What are they trying to test me on? And remember in FRQ4, they're really a lot of times testing you on those ability to rewrite things using those Pythagorean identities, the double angle formulas, the sum and difference. Those are things we have to know. So I'm told that this output value is going to equal 1/2 for function m. I also know that function m is equal to the quantity sine of x plus cosine of x squared. So let me expand this. And if I go through on the right-hand side and I FOIL it out, I would get sine squared plus sine cosine plus sine cosine plus cosine squared. Now, I recognize that sine squared plus cosine squared is equivalent to 1, so I'm going to take these out, replace it with 1, and I have the same quantity twice. Some students are like, does it matter if it's cosine sine and then sine cosine? It doesn't matter. Just like a times b is the same as b times a. So I have two quantities of the same thing. I have two quantities of the same thing, and I've replaced sine squared plus cosine squared with 1. Okay, I'm going to subtract 1 to the opposite side. Remember, on this test, we want the AP readers who are grading our test to understand our entire thought process through our work. 1/2 minus 1 is a negative 1/2. Okay, so now I'm looking at this, and I'm thinking, what can I do? What am I able to do here? So, if I divide both the left and the right, if I divide both the left and the right by 1/2, I would end up with sine of x times cosine of x equals negative 1/4. Okay, And then I'm going to say to myself, and maybe I actually didn't even need to do that. I'm looking back right now, and I'm seeing that I added an extra step that wasn't even necessary. Again, I was working through the steps here, trying to do it ahead of time to save us a little bit of time on this video. But I'm recognizing that really I could have skipped this step because I go right back through it. So at this point, this is where I'm stuck. And I'm like, what can I do? How can I solve this? And so what I remember, just as a little side note here, is you're going to see this. I remember this double angle trig identity. And I remember that the sine of, you could say 2x or 2 theta is equal to 2 sine of theta cosine of theta. Notice how I had that right up here, but that didn't dawn on me yet. That had not dawned on me yet. So what I could have done is really I could have taken this part right here, all this work here as I was trying to figure out a way to get down here, and I could have canceled that out. You're going to see I come right back to that. So at this point, I'm like, well, I want it to match this. So I multiply the left and the right by 2, and I come up with this part right here. So that's what I have on the right. Look at I already had that down. And I have a negative 1/2. I already had that down. So what I'm telling you is I really right now could have taken this part out and jumped right to this step. I could have said negative 1/2 is equal to, and I could have gone, oh, I recognize that this is the same as a sine of 2x. It's this double angle formula. Now, what we're going to do now is we're going to ask ourselves, think of this as being like a u. So u is equal to 2x. And I want to ask myself, where does the sine equal negative 1/2? The sine equals negative 1/2 at 11 pi over 6 and 7 pi over 6. And now I'm going to take that 2x and set equal to 11 pi over 6 and 7 pi over 6. And how do we solve? Well, we need to divide by 2, which is the same as multiplying by 1/2. Let me move it up for us. So I multiply the left and right by 1/2, achieving 11 pi over 12 and achieving 7 pi over 12. But it does not restrict the domain to say just between 0 to 2 pi. It doesn't say any of that. So when I express the answer, I need to share that n could be any integer. So there's no limitation how many times you go around, whether it's forward or backwards, because so that's why it's an integer. It could be positive or negative. What matters is that every single time you land on these exact 2 points. So 11 pi over 6 plus 2 pi n and 7 pi over, 11 pi over 12 here. I wrote it down wrong. 11 pi over 12 plus 2 pi n and 7 pi over 12 plus 2 pi n when n is any integer.